I built a custom web search agent similar to Perplexity that runs completely locally with Llama, can run with almost any Hugging Face model, and also works with OpenAI's GPT models. This is the second in a series of videos where I'll be putting my custom search agent to the test. I've crafted a series of 7 questions in which I'll be running parallel tests for a variety of models to see how well those models perform with the custom search agent. In my last video, we tested a locally hosted version of Llama 3 8 billion against Perplexity. You can see the results of that test on screen now. Perplexity completely outshone the locally hosted Llama 3 8 billion model, as you might expect. This time around, I'm going to be testing the Llama 3 70 billion model to see if we can get a performance uplift on what we did with Perplexity. If you enjoy this content, please give us a thumbs up and remember to subscribe to the channel for more AI and large language model-based content. The code for this project is available to you in the GitHub repo linked in the description to this video. So please feel free to check that out if you wish. Thanks, and let's get into the testing. Joining us on this video, and you didn't see the last one, I want to show you the series of questions that I use to test these models. So the questions range from least difficult here at the bottom to most difficult, and they combine a range of things, including recalling current knowledge that the models have not been trained on, and multi-hop question answering, and also being able to access the internet for sources of information. I will assign a certain number of points, as you can see here, allocated on the right-hand side, to each correct question. And at the end, I'll tally the number of points for the model and put it against that matrix that I showed you already, where I've already ranked Llama 3 8 billion and Perplexity. So the approach is really simple. Using Llama 70 billion is not going to be possible locally because of the constraints of the hardware I'm working with. Therefore, I'm going to be hosting my own inference server on Runpod, and I'll be using Llama 70B that way. If you want to know how to host your own inference server on Runpod, I've already created a video on this. So check that out in the description to this video if you want to get started with Llama 70 billion yourself, or if you'd like to test the web search agent yourself with Llama 70 billion. All right, so we are looking at the agent.py script, which is the center for running my custom web search agent. And at the bottom of the script, you'll notice that there are the options to run through with Llama, the options to run through with Runpod. So this is if you're hosting your own inference server on Runpod, and the options to run through with OpenAI. So in this case, we're working with Runpod because I'm hosting my own inference server. So what you do is you make sure this part is uncommented out and comment the rest of the models. The rest of the servers. So make sure you comment the Llama and the OpenAI and have Runpod uncommented if you want to host your own inference server. And then you select the model you want. So we're testing the Llama 3 70 billion instruct model. Make sure all of these are set to Llama 3 70 billion instruct, and then enter your Runpod endpoint with which you're hosting the model. As I mentioned before, if you want to learn how to host your own inference server, I have a video on this, and I'll link that in the description to this video. So check that out if you want to learn how to host your own inference server so you can work with most of the Hugging Face large language models. All right, the next thing we want to do, once we're all set up here, is there is a setting here, and this is where you can set verbose output to be true or false. So for the first example, I'm going to set it to be true. So those of you that don't know how this web search agent works, or if you haven't seen my previous videos, I can quickly show you via the outputs how the web search agent actually delivers an output. For the remainder of the questions, I'm going to set verbose to false, and it will show a limited output. So a lot of the workings under the hood are going to be hidden from. So just making you aware of that. And you can toggle with this parameter yourself if you're working with this web search agent. If you want to deep dive on this project, I've done a video on this, and I'll link that in the description to this video. So check that out if you want to deep dive from a Python perspective on how this project works. I'll go through everything from the agent schema. So I have set up all the agents to work together to showing you how the code works. Okay, I'm going to pull up my PowerShell to show you how the model works with the first question on our series of questions. So the first thing I want to do is get started with the agent. So I'll do that by running all this down here. So I'll do that by running Python agent.py run. And that gets us started with the script. So you can say, it says here, enter your query. So I'm going to start by entering the first question, which is, when did the capital of Nigeria change? And that will get 1 point if we get this right. So when did the capital of Nigeria change? So if you're new here, past this, you have to get a correct answer. And also you have to return the source of that correct answer. So it's not just good enough to return the correct answer. There must be a source associated with that too. So let's get started. I press enter on that. And the first thing you should see is it should enter the agent workflow with the planning agent. The job of the planning agent here is to come up with a list of queries to ask a search engine to get the right answer to this question. So we've come up with a list of queries. So when was Abuja declared the capital of Nigeria? And it's identified that this is the most important search query. So that makes sense. Now we've actually put this into the search engine. So the search query to put into search engine is, when was Abuja declared the capital of Nigeria? And then we've got a search engine results page. So this is all part of the verbose output that I was talking about. If you set that verbose setting to true, you return a search engine results page, and that's what we returned. And then we selected a best page to pick from that search engine results page, and it's the English Wikipedia site for Abuja. And just to show you that that is indeed coming from the search engine results page, you can see here. And then we've scraped content from that URL, and you can see that here. So this won't be returned when you set verbose to false. Everything in yellow won't be returned. And then we have returned a response. So what we do is the planning agent. So there is actually another agent. The integration agent is supposed to return a response. I think we've had a failure to respond from the integration agent, and that might just be a networking thing. So it will go through again. It will cycle through again, and hopefully the integration agent should actually return a response. But what's happened is we've not had a response from the integration agent. So there's a quality assessment that's also run using a large language model, and it's not passed that quality assessment. So you can see here the response quality hasn't been passed, and that's because we haven't delivered a response. So it says the reason is the response is an error message and does not provide any relevant information. So yeah, there was an error message from the integration agent. We've reached the model's maximum context length. So I think we've actually, the scraped website is too long for the model to return a response. So hopefully we can correct that by selecting a different source. So we've gone through that again. So the planning agent has still selected, when was Abuja officially declared the capital of Nigeria as the most important search. And there are a bunch of other searches here as well. So it's adjusted the search. When was Abuja officially declared the capital of Nigeria? And that's what we've put into the search engine. We've returned the search engine results page. This time we've chosen a different source, the Britannica.com kids article on Abuja. Let's just make sure that is actually one of the ones. Yep, it is. It's one of the sources. We've returned some information from that. And here we go, the integration agent, whose job it is to either, so the integration agent will summarize that information pulled from the source and give you a response, and it's supposed to also give you a citation. If there is insufficient information to answer the question, it will provide feedback to the planning agent, who should change its search approach to actually respond to that question. So in this case, we have an answer for the integration agent, and that answer has been quality assessed, and the pass has been true. And we also give a reason. So the reason is the response is well-structured, coherent, comprehensive, providing a clear answer to the query with relevant citation. It acknowledges the limitations and the research and suggests additional research for further information. So it meets the requirements, true. And then we deliver the final response. And that final response is just a regurgitation of the last response from the integration agent, given that it has passed the response quality assessment that you can see here. So let's read the final response. So based on the research provided, I can answer the query as follows. The capital of Nigeria changed in 1991, which I believe to be correct. According to the research, Abuja officially became capital in 1991. And then we have the source here as the kids.britannica.com/kids article. And that was obviously returned from this search engine results page. So let's just have a look at that. So I'm opening this source. We pull that up. Send. Do we have anything about 1991 here? Abuja officially became the capital in 1991. So it seems like it's pulled from that source, so we can assume it's pulled from that source. And we have that source linked in the response here. So there's the source. It also says the research also mentions that the government started planning the new city of Abuja in 1976, and it took more than 10 years to build the city. So let's just check the source to make sure that that is true. Yeah, the government started planning the new city of Abuja in 1976. It took more than 10 years to build that city. To me, that looks like a pass. So we will give 1 point to Llama 370 billion because it seems like it has managed to pass that question. Okay, we will test the next question, which is going to be slightly harder. So stay tuned for that. All right, so for the sake of transparency, I've decided that it's best to leave the output as verbose because even from the last example, I saw that if things do start to go wrong, it's easier for you guys to see how the custom web search agent resolves that if the output's verbose. So I will leave that as it is. So we'll continue to see how everything works under the hood. Now it's time to move on to the second question. So I'm going to start the agent, -agent.py run. And it's asking to enter the query. So the second question is, what is the current population of NYC? So let's write that. What is the current population of NYC? And the reason this is harder is because the current population does obviously move. So we'll see how the custom agent can resolve that issue. So the planning agent has come back with a response. So it says, the most important search query is current population of New York City. That seems sensible to me. And then we've got other search queries that also seem sensible. So New York City population 2024, that is sensible. And that shows you that the custom agent also has an awareness of time and date because it knows that we're in 2024. And that's based on how I've actually designed this custom agent workflow. So when you go through the Python code yourself, you'll see how I've done that. I've given an awareness of time. So we are now stepping into the search engine, and you can see the search query here, current population of New York City. So we've had an error retrieving the content from census.gov. Says the connection has failed. So we've had a read timeout. So I could probably adjust this so we don't get this type of error by increasing the read timeout. But anyhow, the way the agent is set up is it should retry a number of times or try a different page. And we have actually tried a different page. So I'm going to scroll out. So yes, after hitting that current population of New York City, we have identified the best page, which is a wiki page. And obviously the best page is identified by a large language model. So it's just basically feeding this search engine results page to another large language model, which then identifies the best page based on the URL and the descriptions available. So let's just make sure the wiki page is there. So it is. It's the English wiki, New York City. And that's the one we've chosen. And that's the one we've also scraped. Hopefully we're not exceeding the context length. You can see that we have actually exceeded the maximum context length of 8,192 tokens. We've requested 9,000 585. So this is a limitation, obviously, with the Llama 3 70 billion model. It does have a short context window. So when you're doing these types of RAG type applications where you're drawing in context, well, this is, I guess this is a crude version of RAG, you might reach some limitations if you're using Llama 3 70 billion. So you might want to use a model with a longer context window for these types of applications. So anyway, we step back into planning agent, and it's adapted its search. So it says New York City population 2024 estimate. So we've put that back in to the Google search, and we've returned our search engine results page. And we have picked up the best pages, www.nyc.gov/site/planning. Let's just make sure that is one of the sites. It's the top one. So we have selected that from the search engine results page, and we've returned some information that we scraped from that URL. And the integration agent has said, unfortunately, the research provided does not directly answer the query about the current population of NYC. The research content appears to be a web page from the New York City Department of City Planning, but it does not provide a specific estimate of the current population of NYC. Based on the research, the following questions have been answered. The web page provides information about the population estimate and trends in NYC. It mentions the availability of population estimate reports, including the New York City Population Estimate Report Vintage 2023. However, the following questions remain unanswered. What is the current population of New York? What is the latest estimate of the current population of New York City? To provide a comprehensive response to the query, I need more specific information about the current population of NYC. I recommend refining the plan to include more targeted searches, such as searching for the New York City Population Estimates Vintage 2023, or searching for recent estimates from reliable sources like the United States Census Bureau. So there's the feedback to the planning agent. The research provided does not directly answer the query about the current population of NYC. The plan should be refined to include more targeted searches for specific population estimates, such as the New York City Population Estimate Report Vintage 2023, or recent estimates from the United States Census Bureau. So then we have the response quality assessment, and that is the pass there is false. And then it gives a reason the response does not directly answer the query about the population of NYC and lacks specific information, making it incomprehensive and not relevant to the query. So it doesn't pass that, but that's good because we've got feedback to plug back into the planning agent. So that's what we have. So based on the query and feedback, I have generated the following search queries to find the answer. So the most important search is now New York City Population Estimates Report Vintage 2023. So then we put that into the search query. So New York City Population Estimates Report Vintage 2023. So let's see if we can actually find it. So this is our search engine results page. So we're actually back to the same source. So it looks like we're stuck in a loop of answering questions because we're back to this nyc.gov site planning level. So let's make sure that's actually in here. Yeah, so it's this site here. So ideally what it's supposed to do is it's supposed to change the source that it's pulling from, but instead we've actually stepped back into the same source. So the way the agent is set up is if it's visited a source already and couldn't answer the question based on that source, it will choose another one. It seems to have selected the same one. No worries, it will pass back through. So we've got some information from the integration agent. Again, I'm not going to read all of this, but it's basically along the same lines of delivering feedback because we couldn't answer from that source. So we have, based on the feedback from the integration agent, we have adapted the search from the planning agent. So now the most important search is United States Census Bureau NYC Population Estimate 2024. So hopefully we do pick up a different source of information. So we have our search engine results page, and we are back in to searching for this planning data maps NYC population page. So it looks like we're stuck in this loop of just picking from that same site, which isn't good. And that's likely a bug. I can't work out if that's a bug with the custom agent or if it's a bug with how I've set it up to select sources from the search engine results page. It's likely a little bit of both. Let's go through it again to see if we can select a different source. So here we go. So this time around, we have selected a different source. So instead of selecting the planning page, we selected the census.gov, newsroom, press release 2024. So let's just make sure that is one of the sources here. Census.gov, newsroom, press release 2024, population estimates.html. And that's what we selected, and we return a response. Hopefully it is within the context window. So the integration agent has provided a response here, and it's passed the quality assessment. So let's read what it says. So final response is, based on the research provided, the current population of New York City is not explicitly stated. However, according to the United States Census Bureau's vintage 2023 population estimates, the population of New York City as of July the 1st, 2023 is approximately 8.258. So 8.3, let's just say 8.3 million. And that's referenced in table 3. So actually, let's get the exact result. So it's 8,258,035. That's the population. So I'm going to enter this source to make sure that we are pulling from the source. So remember that number, 8 million, put it to the side here. So we are saying the population is 8,258,035, and that's pulled from table 3, the population of New York. So let's have a look to see if it is within this source. I'm going to do a Control F to find that number 825. Is it within here? Here we go. And guess what? It's also a reference to table. So that is a pass because that is directly pulled from that source. You can see 825,035. That's directly pulled from table 3. So that's a pass on that question, even though it did take a while to get there. And, there were numerous difficulties in terms of selecting a different source from the one it had already visited. And there's probably something about the agent logic that could be improved there to make sure that it does select that source right away instead of going back into the same source. But when it did find the source, it gave us an answer, and it stated that, look, this isn't the current population, which is fine. But based on the source it did find, it gave us a population of New York City and caveated that this was as of the July 1st, 2023. I think this was a census. So I'll give that a pass. I think that is worthy of a pass. And bearing in mind, getting the current population for any city is going to be difficult because you need to, obviously that number is always moving. So that's 2 points. Let's move on to the next question. So far, so good with the Llama 3 70 billion model. We've managed to answer the first 2 questions correctly, already outshining its smaller brother, the Llama 3 8 billion model. So let's move on to the third question out of 7. So I will start by starting the agent. Agent.py run. So the agent is started, and the third question is who won the Premier League 2023-2024 season. Obviously, this is based on current events because the Premier League season ended 2 weeks ago or so at the time of recording this video. So that shouldn't be in the training data for any model. So let's see if we can get an answer to this based on current events. And I expect it should be able to do this given its answer to the previous 2 questions. So who won the Premier League 2023-2024 season? This might be getting repetitive at this point if you watch my other videos, but the Premier League is the top soccer league in the UK for my American audience. So let's find out who won. So we have a response from the planning agent, and I'm not going to read all of this, but it's identified the most important search as Premier League 2023-2024 winner. We put that into the search engine, Premier League 2023-2024 winner. Hopefully we should return a sensible search engine results page. Okay, so that was fast. We have a search engine results page, and we've picked the best page as buttervip.com. Let's just make sure that is one of those. There we go. So just to show you, it doesn't always just pick the top. It is fully up to the large language model to decide which page is the best to pick from this search engine results page. So we've picked this one, and we have scraped that data, and the integration agent has provided a response. So I won't read that out until we see what the quality assessment says. By the way, the quality assessment is also done by a large language model, if that wasn't clear. When I say a large language model, I'm talking about the Llama 3 70 billion model here, obviously. So we've passed the quality assessment. So let's see the final response. So based on the research provided, Manchester City won the 2023-2024 Premier League season, breaking one of the greatest records in history by becoming the first team to win the league title in 4 consecutive seasons. And then we have the source here. So that's correct. Manchester City did win. Let's make sure that we have pulled that from the source. So I'll pull up the source. Let's re and close. Let's close that. There we go. So we have so we have our response here, and straight away we can see Premier League, Manchester City win 2023-2024 Premier League, breaking one of the greatest records in history. That seems almost verbatim from there. So first time in history a club wins the league title in 4 consecutive seasons. So that is another pass for Llama 370 billion. So the model is doing pretty well so far. We are on to the 4th question, and this 4th question is going to be the first multi-hop question in this series of questions. So the multi-hop question requires you to answer more than one question to ultimately get the final response. I'll show you, it will become more clear what that is when I pull up the example. I'll start off by starting the Python agent of Py run. As usual, prompted to ask the query. The query in this case is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Now, you first need to know who was the loser of the boxing match between Tyson Fury and Usyk, and then you can find out the birthplace of that loser. That's where it becomes multi-hop. And any of you that know anything about boxing, you'll know that the boxing match between Tyson Fury and Usyk only recently just happened. It's not going to be in the training data for this model. What is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Let me just make sure I have that correct. What is the birthplace, the loser of the boxing match between Tyson Fury and Usyk? It will be challenging because you first need to, as I said, identify the loser of the boxing match between Tyson Fury and Usyk, and then you can identify the birthplace of that loser. So it has identified Tyson Fury versus Usyk boxing match result as the most important question. And that's going to help it identify the loser. And it's already mentioned here, these searches should provide the necessary information to determine the loser of the boxing match and their birthplace. Okay, that makes sense. Let's see how the custom agent can proceed with that. Okay. Search query, Tyson Fury versus Usyk boxing match result. We've returned a search engine results page. We selected the ESPN.com as the best source. And just to make sure that that's actually coming from our search engine results page, ESPN.com/boxing. I believe it's this one. Yes, it is that one. And then we have a result. Great from there. And then the integration agent delivers a response. So we're going to wait for the quality assurance agent before I go into what this integration agent is actually saying. Take time to just do this quality assurance. But it shouldn't pass because I gather it doesn't know the birthplace. Yes. So what's happened is the response hasn't passed, and here's why. The integration agent says, based on the research provided, I can answer the query as follows. The loser of the boxing match between Tyson Fury and Alexander Usyk is Tyson Fury, which is correct. According to the research, the article states Alexander Usyk, 22-0, 14 knockouts, who entered with the WBA, IBF, and WBO belts, captured Tyson Fury's, I won't go into that, WBC and lineal titles to become undisputed. Right, and that is correct. Anyone that watched the boxing will know that. However, the research does not provide information about Tyson Fury's birthplace, and that's what we want. We don't want it to make up that information. We want it to be sourced. Therefore, I must request additional research to answer this question. And then we've got feedback to the planning agent. The research provided answers the following questions. Who won the boxing match between Tyson Fury and Alexander Usyk? What were the titles held by each fighter before the match? The research does not answer the following questions. What is the birthplace of Tyson Fury? So we're stepping back into the planning agent. Planning agent, based on the feedback, I've generated the following search queries to help answer this question. Most important search query, Tyson Fury's birthplace. Excellent. That's exactly what we want. And we've returned the search engine results page for that. Hopefully we've chosen a reliable source. So we've picked up Wikipedia. It's simple.wikipedia.org, wiki Tyson Fury. Let's make sure that that is, yep, so that's the top one. And we've returned something here. And we've got another response from the integration agent. And this time it actually says false. It doesn't meet the requirements. So I wonder why that is. Integration agent, based on the research provided, I can answer as follows. The loser of the boxing match between Tyson Fury and Usyk is not mentioned in the research. There's a problem here. However, I can provide information about Tyson Fury's birthplace according to the research. Tyson Fury was born in Wivenshaw, Manchester, England. And we have this https://simple, which is the source feedback to the planning agent. The research provided answers the following questions. What is the birthplace of Tyson Fury? The research does not answer the following questions. Who won the boxing match between? So there's a problem here. It thinks it needs to answer the question, who won the boxing match, but it already did. But it has the integration agent and the planning agent aren't feeding that information back to each other in the correct way. So now we're getting a false response because it says the response is incomplete and requires additional information to answer the original query. So this is interesting because we've stepped back in. So most important question, Alexander Usyk birthplace. So that's interesting. I'm not sure why it's identified that that is an important question. But then we've pulled some information about Alexander Usyk's birthplace, and now we've stepped out of it. So that's interesting. It seems to have failed to answer that question, but it did answer the question on the way in. And I think that is not to do with the large language model. That's definitely to do with the logic in the Python script. So I'm going to see if I can make a correction to the logic, and I'm going to retry this question. I have figured out that there were a few things wrong with the logic in terms of the retry mechanism for when sites were not scrapable. So I've made a small correction to that. And there was a bit of correction I made to the prompting of the agent itself. So specifically with the integration agent, what I noticed is that it wasn't taking into account that some of the responses that it generated may partially answer the question already. So I've explicitly stated this in the prompting now. So what I've said is it's already has knowledge of its previous responses. But I've also said your previous responses may partially answer the original user query. You should consider this when generating your response. And I've also given it a reminder of the original user query. So that has been added into. And my hope is that now we should get a fairer approach of assessing the Llama 70 billion model. So this is the Llama 3 70 billion model, obviously, because I think where it was failing on the last question wasn't so much to do with the model itself, but more to do with how I'd set up the custom web search agent. So, okay. So I think the logic should be sound now, and I'm going to retry that question 4. So I'm going to write Python agent.py run. And to record what the question was, I'll step back into the question. So the question was, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Okay. So again, we've stepped back in with the planning agent, and it's identified, which I think you'll agree is correct, Tyson Fury versus Usyk boxing match result. So we want to find that. So this should all look familiar based on the first run. And we have returned our search engine results page. And I'll just zoom through this because I think it should all work as we expect. ESPN.com boxing/story. And just to make you comfortable that it's actually pulling from the search engine results page, we can see there it's pulling the ESPN.com result. And it's been logged as one of our visited sites. So this context is obviously straight from here. Okay, so the integration agent has identified the loser, but it still says, okay, we still need to answer what is the birthplace of Tyson Fury, which is correct. So Tyson Fury was the loser for if you haven't followed that. So the loser of the boxing match between Tyson Fury and Usyk is Tyson Fury. That's correct. But we still need to identify the birthplace of Tyson Fury because that was the original user query. So yes, the response from the quality assessment is a false. It hasn't passed that. And the reason is obvious there. It's not comprehensive as it does not provide the birthplace of Tyson Fury, which is the main question being asked. And that's right. So now we're going back in. So the planning agent has identified question to answer is Tyson Fury birthplace, and we're putting that into the search engine. We've returned a search engine results page. We move this to the side. So we return the search engine results page, and we're picking out the best page, which is a wiki on Tyson Fury. And we have, there we go, simple.wiki. So that's the page we picked up. And now we have the integration agent. Based on the research provided, I can answer the query as follows. The loser of the boxing match between Tyson Fury and Usyk is not explicitly mentioned in the research. However, according to the research, Tyson Fury is a British professional boxer born on the 12th of August, 1988 in Wivenshaw, Manchester, England. Right. Okay. So I think this does actually conclusively show that there's an issue here with the large language model, with Llama 3 70 billion, understanding that, we have already answered this question. We answered the question in the first step. And we got the fact that Tyson Fury was the loser of the boxing match, but it seems to not understand that we already know that Tyson Fury is the loser of the boxing match. And now we're just figuring out where Tyson Fury was born. And you might wonder, well, how would the large language model know that? How would the agent workflow know that? There is a feedback loop here. So it's supposed to know the previous response from the integration agent. So the integration agent knows all of the responses that's previously given, which should include the fact that it already identified that the loser was Tyson Fury. But somehow it's not able to, maybe it's the reasoning workflow is not able to, or the reasoning capability of the model is not able to pick that out. So I think that's an issue there with the model, actually. Actually, to correct that statement, I think maybe it's a mixture of an issue with the model and also maybe the way I've prompted the model. It will be interesting to see how this works with some of the OpenAI models to see if we can get past these types of questions. But for now, it seems like it's an issue with the model. So yeah, as you can see, we're stepping back into this workflow because it says, who won the boxing match between Tyson Fury and Usyk? That's the question still unanswered. And you can see the planning agent is itself getting confused because now it's still trying to still identifying the most important searches, Tyson Fury's birthplace. So this is breaking here. And we're back in. We've selected the search engine results page. And again, we are failing because it says it doesn't provide the outcome of the boxing match between Tyson Fury and Usyk, and that doesn't matter so much. What matters is identifying the birthplace of the loser, and we've already done that several steps back. So we're stepping back into this workflow, and I think this is probably going to be a fail on this question. I think we can say that conclusively, and this is even after I've made some changes to the logic, which I thought would resolve this issue. But yeah, it looks like the model itself is having difficulty understanding that it already knows the answer to this. So that's a fail for the model on 0.5. And that is interesting, on question 4. And that's interesting because that's the first question that this model, this Llama 70 billion model has failed. See, and you can see here, what is the birthplace of Tyson Fury is being marked as a question that is unanswered. And we have already answered that question. And I just want to show you what's happening in the background here as well, because you might be wondering how this is actually feeding in back to the integration agent. But essentially what we have here is we have this memory.json, and every time the integration agent provides a response, it's stored in this memory.json. So you can see all of the responses should be in here in this memory.json file. And that memory.json file is read back into the integration agent. So it has an awareness of all of the context. I'll show you where that's read back in. Here we go. So we saved the feedback, memory.json. And then here we go. So we read the feedback, and that feedback is passed back to run the planning agent. And it's also passed in to the integration agent. So previous response, the feedback, and that feedback is that memory.json file that I just showed. So the integration agent should have an awareness of the previous responses it has delivered in order to deliver the next response. That is actually a failure in the logic of the failure in the reasoning capability of the model. And I'll show you how that's prompted once again so you get a better understanding. If I go into prompts.py, I go specifically to where we're feeding that, we're putting that feedback in. So the previous responses. So this is for the integration agent. We can see here are all your previous responses. And then I've said your previous responses may partially answer the original user query. You should consider this when generating your response. So yeah, there's an issue there. And I think I'm going to have to chalk that up to the model not having the reasoning capabilities to decipher this prompt. Let's see if we've finished the chain. So we have finished the chain. The final responses, So apparently now we meet all the requirements. So the final response is, based on the research provided, I can answer the query as follows. The loser of the boxing match between Tyson Fury and Usyk is Tyson Fury. According to the research, the article states that Alexander Usyk, Tyson Fury split decision over 12 rounds. And we can see the source here. Let's pull that source up. So I might take that back because it might have actually gotten to the answer. Yeah, well, there you go. Yeah, so that's correct. Additionally, the research provides information about Tyson Fury's birthplace, stating Tyson Fury's nickname due to King, hometown, Manchester, England. Source. Right. So I think it's kind of managed to find it from the same source after several iterations of running through that. So the birthplace of Tyson Fury is Manchester, England, but it has pulled it from this same Wikipedia source, Tyson Fury versus Alexander Usyk. And let's just go again. See, Manchester. So Manchester's mentioned once as the hometown, but it doesn't mention anything about the birthplace. So I am still going to chalk this up to being a fail because we already identified the birthplace. Birthplace was identified a few steps back. So this is the same agent flow. Birthplace was definitely identified a few steps back here, and I believe it was Wivenshaw. Yeah, so it should have picked up the birthplace as Wivenshaw, Manchester. So that's a fail. Even though we did get to a response in the end, it's not the response that I would have expected. All right, so question 4 is a fail. We'll move on to question 5. And we will see how well we can do on question 5. All right, we are moving on to question 5 after failing question 4. And question 5 is going to be about finding cheap flights. So I'm going to start the Python agent, Python agent.py run. And the next thing we want to do is we want to ask the question. So the question is, find me the cheapest flight to Barcelona from London for one adult leaving next month. Okay. So realistically, this is a tough question to answer because, first of all, how do we know it's the cheapest flight? It's I think you can search research engines, but you have to just pull from one source and you're relying on the data from the aggregator that you can pull from to identify whether something's the cheapest flight or not. In the past, the scraper I've designed has had issues scraping from websites that are travel aggregators. So I know that could be a potential issue here too. But let's see how well we can do. I'm not going to penalize it if it doesn't find the exact cheapest flight. But as long as it gets to a flight and it provides a source of that information, I would pass it. So let's have a go and see what the custom web search agent can do. All right, so the planning agent has come up with a response. So it says, the most important search is cheap flights from London to Barcelona next month, which is correct. And again, you can see that it has an understanding of where we are, because at the time of recording this video, we are in May 2024, and it knows, flights for next month is June 2024. So that is working well, as it did in previous searches that required some understanding of date and time. So you can see here, we're having some issues accessing, trying to retrieve content from Expedia. We've also tried from Kayak now. This is the thing about my approach in terms of trying to access some of these aggregator sites. It does fall down when it comes to that. So we're going to retry a few times and see if we can get there. I know this is a known problem with the custom web search agent, but we have managed to get something. So we've managed to get something from Skyscanner, and you can see there we've got our search engine, cheap flights from London to Barcelona next month. we return the search engine results page, and we pulled up skyscanner.com/routes London, Barcelona, London to Barcelona.html. And let's just make sure that is one of the, so this is it. Skyscanner.com routes London, Barcelona, London to Barcelona.html. Brilliant. So we pulled some information. Hopefully this isn't exceeding our context window. Great. So we have pulled some information and the integration agent has returned something. And as usual, I'm not going to read out the response until we pass the quality assessment, because it doesn't count unless the unless the quality assurance agent says it passes. So it does. So response from the quality assessment says passes true. And it, we've got a reason here. So the response is well structured, directly addresses the query, provides multiple options, and includes a source link to support the information. Brilliant. So here we go. We've got a final response. So we got a final response based on the research provided. Here's a comprehensive response to the query. The cheapest flight from London to Barcelona for one adult leaving next month can be found with Ryanair, with prices starting from £31 per passenger. This is based on the return flight with Ryanair, departing from London Stansted on Sunday, 23rd June 2024, and returning on Thursday, 18th July 2024. So that's the cheapest flights. And then we've got other flights listing here at £34 to £35. So let's pull up the source. Accept all. So we have our cheapest flight from £31, and that is indeed with Ryanair. So I would chalk that up as a pass. That's done pretty well. So we have all of the flights here just to make sure it is the cheapest on this page. It does appear to be the cheapest on this page. So that's fantastic. That's a pass on question 5. So we'll move on to the penultimate question, and let's see how well Llama 370 billion does on the penultimate question, which will be another multi-hop question, I believe. So we're moving on to the penultimate question, having passed the last question. So the penultimate question is going to be a multi-hop question. I'll start the agent. This question was inspired by a research paper. I'll link that in the description to this video. But if it sounds peculiar to you, it's because it's a multi-hop question that was artificially comprised by combining single hop questions together. So I believe this question has 4 hops. I'll read it out to you. So the question is, how many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country, right? So the original question ended that was governed by Prezeres' country, but I have swapped that out to just make it a little bit more coherent. So I'll write the question, how many Germans live in the colonial holding that was holding, in Aruba's continent that was governed Cristiano country. Okay. So the key thing here is that it's a multi-hop question because first of all, you need to understand that Aruba is in South America. Then you need to understand that Ronaldo's birthplace is Portugal. So then it's Portugal's colonial holdings in South America, which is Brazil. And then how many Germans are in Brazil, which is going to be roughly about 5 million. So there's 4 hops there. It's relatively complex. Let's see how well this search agent does at answering that question. Okay, so the planning agent has identified it's a complex question. So that's quite funny. What a complex question. Here's some potential search queries to help answer this question. So what is Cristiano Ronaldo's country of origin? Correct. What continent is Aruba located in? What is the colonial holdings in Aruba's continent governed by Cristiano Ronaldo's country? And how many Germans live in the colonial holding? Okay, so I think that's a fairly good breakdown of the logic. And notice it's kind of got 4 hops here, which is aligned with our 4 hop question. So the first thing is Cristiano Ronaldo's country of origin. So we're stepping in there. I mean, that is a fair way to do it. And you can see we have returned the search engine results page. And, at this stage, I think we trust that it pulls from the search engine. So we've pulled the wiki article, obviously here. We scrape that. And we're exceeding the number of tokens. So this is going to be a problem because I think we're going to exceed the number of iterations in answering this 4-hop question. But no worries, if it does fail, I will restart it and just increase the number of iterations as possible. But essentially now it has to go look for another source because it has not been able to hear from this wiki site because the context is too long. So that's an issue with Llama 3, 70 billion. The context length probably needs to be increased for it to be, well, I'm not going to say for it to be useful. It is useful, but it would be better if there was an increased context length. So we're starting again. Hopefully we haven't gone back into the Wikipedia. No, we haven't. We haven't gone back into the Wikipedia. So we've chosen another source, which is good. This could probably be enhanced by adding an additional retrieval step on top of the information here. So there could be some chunking and then an additional retrieval step to make sure that we're not pulling too much context. But I believe that all adds latency to this system. And also it's a lot more effort to code that out. But it's something I will think about doing in another video when I do a series on RAG. So we've returned something from the integration agent, and we don't expect this to be a pass. This is going to be a fail because there are still a few questions that we need to answer. So we've answered Cristiano Ronaldo's birth country, I believe. So it says, I'm happy to, however, I must point out the original plan provided is not suitable to us. The plan seems to be based on incorrect assumptions and lacks relevant information. Upon review and research provided, and notice that it only contains a biography of Cristiano Ronaldo, which does not provide any information about Aruba, colonial holdings, or Germans. To answer the original query, I would need more information about Aruba's continental holdings and Cristiano Ronaldo's country. Unfortunately, the research provided does not contain this information. Here's a revised plan. What continent is Aruba located in? So we've got some things for a revised plan here. So apparently that doesn't contain any information about where Cristiano Ronaldo was born. The biography seems unlikely, but apparently it doesn't. So we're stepping back into the integration, into the planning agent. Let's start afresh and come up with a new set of queries to answer this question. Here's the revised plan. What country is Aruba located in? What continent is Aruba located in? Apologies. What country has a colonial holding in Aruba's continent? What is Cristiano Ronaldo's nationality? Is Cristiano Ronaldo's country the same as the country with a colonial holding in Aruba's continent? How many Germans live in the colonial holding? Okay. So we are stepping through. Again, we've returned our search engine results page for countries with colonial holdings in South America. So I think it's not going to get it because what we wanted is what continent is. Oh, that's interesting. It seems to have picked up that Aruba is in South America. So now we're picking up countries with colonial holdings in South America. So that's kind of a weird shortcut, actually. It's not following the logic of the planning agent, but the large language model that's in charge of coming up with the search engine queries based on what the planning agent says has made a shortcut and just said countries with colonial holdings in South America. So I wonder if based on this information, then the integration agent can get a response to that query. So let's have a look. I'm happy to help. However, I must point out that the research provided is not sufficient to answer this query. Upon reviewing the research provided, I noticed that it only contains a list of former colonies in South America, which does not provide any information about Aruba, Cristiano Ronaldo's country, or Germans. To answer the original query, I would need more information about Aruba's continent, Cristiano Ronaldo's country, and colonial holdings in question. Unfortunately, the research provided does not contain this information. Here is a revised plan to answer the query. What continent is Aruba located in? What country has colonial holdings in Aruba's continent? Is Cristiano Ronaldo's country the same as the country with colonial holdings in Aruba's continent? How many Germans live in the colonial holding? Okay, so all sensible. I think it could have gotten that information from the wiki article, former colonies in South America. But it is being strict and it's trying to follow strictly to that plan that the planning agent has come up with. So let's see. And we're back in, you can see the planning agent has started afresh and it's basically picking up some of the original questions. And these are good questions. I think these work. I'm not going to repeat them because it's pretty much the same as what it's picked up. But what's happening here is this agent. So it's not really an agent, but it's more like a process that's powered by large language model to give us a search query based on what the planning agent comes up with. So it's basically just formatting this as a JSON and turning it into a search query. And it will usually take the one that's identified as the most important. But what's happening is it's just warping it. So instead of taking this and just returning what continent is Aruba located in, what it's doing is it's searching, it's providing as an input to search engine countries with the colonial holdings in South America. So that is a failure with the model, actually. So that's almost like a hallucination. That's not right. We're not wanting this. We're wanting to search what continent is Aruba located in, and it's not able to pick that up. So now we're going to be stuck in this loop of looking at former colonies, and the integration agent isn't going to like that. So it's pointing out again that the research doesn't contain the information we want. And yeah, we're stuck in this loop. We're stuck in this loop of identifying colonial holdings in South America and then coming back out and the integration agent telling us it doesn't have the information to answer the question. So I believe it's probably going to keep going like this until we run out of iterations. So we're back at the planning agent again. And yeah, there's a misstep here. It's just not listening to what the planning agent is saying. So the planning agent is saying, look, search what continent is Aruba located in. And the large language model that's responsible for turning that into a JSON isn't doing that. And the reason we turn it into JSON is because the planning agent can return our search request in whatever form it wants. It's never going to be standardized. It's unstructured. So we want to use another large language model with JSON mode to take what the planning agent suggests to do and turn it into a search. And yeah, it's failing to do that at this stage. And you can only put that down to a failure in the model rather than the approach, because it has worked for previous approaches. So it has worked on previous questions. It worked really well, but this time around, for some reason, the model is not doing it. So the integration agent, again, is spewing the same stuff. And I believe we are probably at maximum number of iterations at some point. You can see all the sites we visited too in trying to answer this question. Yeah. So you can see the response doesn't meet the requirements, is false. So it hasn't actually answered the question. We haven't even gotten to answering the first question about what continent is Aruba located in. So I'm going to that as a fail for the penultimate question, which is question 6. So that fails on that response. All right, next. So we're going to move on to the last question, and then I'm going to tally up the score and see where the Llama 370 billion lands on the chart compared to Perplexity and obviously the Llama 8 billion model that I tested previously. And then I'm going to give you my thoughts about Llama 370 billion as an agent for web search, just to be clear. So we've reached the final question on the series of test questions that I have. I'll start up the agent, as usual, Python agent or PyRun. The final question is another multi-hop question. As you might guess, the multi-hop questions appear to be the more difficult ones for the Llama 370 billion model to answer. But let's try the final one. You never know. As I've said in other videos, these models do have the ability to surprise me from time to time. So the question is, what is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? So there's a few things here. There's current knowledge, so we need to rely on web search because the 2023-2024 season is not going to be in the model at the time of running this. The team that finished, you need to know the team that finished second in the 2023-2024 season, and that's the Premier League season. And that team is Arsenal. Then you need to know that Arsenal played their last match in London. Then you need to know that the largest city north of London is Birmingham. And then you need to get the current weather forecast for Birmingham. So there's quite a lot there. It's complex. Let's see how well this web search agent fares in doing this. So what is the current weather for in the largest city north of the city where team that finished second in 2024 season played its last. Right. Again, this is a multi-op question comprised of many single-op questions. So I know it's not grammatically perfect. I'm really just trying to push the limits of this web search agent. So let's go. So the planning agent has picked it up. And the first thing is the most important search is 2023 Premier League standings. That makes sense, and that's fair enough. And notice this time round, we're not hallucinating this search query. It has literally picked up 2023-2024 Premier League standings. So that's what we want. Remember the last example where it was actually changing our most important search and, searching something that we weren't looking for, or the planning agent didn't identify. So we've returned our search engine results page and we've isolated a best page as premierleague.com/tables. And have we got premierleague.com/tables here? Yep, we have. So let's pick this as the best result. We've returned the information here. So we are exceeding the context level. Again, so this is a problem. This is a real problem for this custom search engine approach. So yeah, we'll need to maybe when on future tests, we'll test a model with a longer context window to see if we run into the same issues, but this is definitely a problem. So now we've gone back and planning agent has adjusted its query. So it's said 2023-2024 Premier League standings. So remember, there's no feedback here from the integration agent. So if it is just returning the same thing as it said before, that's because no feedback was provided from the integration agent because the site that we visited exceeded the context length. It looks like we've got a slightly shorter context this time round. Hopefully this means that we can actually return a response from the integration agent. Hopefully. And that's you got that pulled out from ESPN. Great. So the integration agent has returned a response. So it says, based on the research provided, I can answer some parts of the query, but not all. Here's what I can provide. According to the research, the 2023 Premier League standards are available, and the team that finished second is Arsenal. That's correct. However, to answer the rest of the query, I need more information. Specifically, I need to know the home city of Arsenal, the largest city north of Arsenal's home city, the location of Arsenal's last match in 2023-2024 Premier League season, current weather forecast in the largest city north of the city where Arsenal played its last match. So I would say that it should identify that question 3 is the next most important question that needs to be answered. So the research provided answers question 2, which team finished second in 2023-2024, correct? The research does not provide answers to 3, 4, 5, and 6. There is no, interestingly enough, there is no 5th and 6th question. So this is a hallucination. So you can really see this model starting to break down. To answer the original query, we need more research on the home city of Arsenal. I'm not sure we need that. We don't need that to answer the original query. We just need to know where Arsenal played its last Premier League game, the largest city north of that city, and the location of Arsenal's last match. So this is really starting to break down now. And I'll be surprised if we get the response, because you can see the logic is of the model, of the large language models, failing now at this stage. So this is a model failure. The response quality assessment is obviously false because we haven't answered the question. And now we're stepping back, and the planning agent has identified most important searches. What is the home city of Arsenal? Again, that's the red herring. We don't need to know that. We just need to know where Arsenal played its last game, and then we can go from there. So saying what is the home city of Arsenal, complete fail in reasoning, but we return the search engine results page, and we have returned a wiki, and it's probably going to exceed the context length, which it has. So it's not surprising with Wikipedia, to be honest. So we're stepping back in, and we'll probably choose a different page, which we have. We've chosen Arsenal's club overview. So the integration agent should pick this up, and it probably will find the home city of Arsenal from here, but it's the wrong question. So according to the research, Arsenal finished second in the 2023-24 Premier League. So good. It had that awareness, which we wanted to have. The home city of Arsenal is London. However, to answer the rest of the query, I need more information. Specifically, I need to know the largest city north of London, the location of Arsenal's last match in 2023-2024 Premier League season, current weather forecast in the largest city north of the city where Arsenal played its last match. So fine. So it's getting there slowly. We've got 2 of the questions answered, but there are some hallucinations there. Because even now, the research does not provide answers to questions 2, 3, and 4. There are only 3 questions here outlined. So yeah, the model is really starting to break down. So we're asking, what is the largest city north of London? It is true that Arsenal's last game of the season was in London. Let me just double check that. Yeah, Arsenal's last game of the season was in London, but notice that the way we've gotten there, the reasoning trace of getting there is incorrect. Because what we're now identifying is what is the largest city north of London. And the way we got to London was by identifying that Arsenal's home city is London. So we have pulled some information that we're going to enter the integration agent. I think we're just under the context. Good. So it should pick up Birmingham, but I think we're going to run out of iterations before we actually get to a complete response here. So the integration agents. So based on the research provided, I can answer some parts of the query, but not all. Here's what I can provide. According to the research, the largest urban agglomerate in the United Kingdom in 2023 is London, with an estimated population of, fine. However, to answer the rest of the query, I need more information. Specifically, I need to know the team that finished second. So this model is really breaking down now at this point. The more iterations we get through, it seems like the model is being overwhelmed with the information we're putting into its context. And it's not actually able to answer the questions that are needed to get to the final answer. So it did initially look like it was getting there slowly. It looked like we were iterating there, but you can see it's not really answering those questions. Now we've gone on a tangent. The planning agent is getting confused by the feedback, and now it's saying most important search is what is the home city of Arsenal. We've already done this. So again, it's kind of like how we did in the last thing. We're stepping back and we're looping through. And I think basically with this question and this approach, we're pushing the limitation of this Llama 3 70B model. And for me, this just makes it more interesting to see how well we do with the OpenAI models. So how does GPT 3.5 Turbo compare to Llama 3 and Perplexity by itself, for example? So I don't think we're going to get to the answer here. I'm just going to wait for this to time out, because I think it will reach the maximum number of iterations pretty soon. I think probably maybe on this turn, if not this turn, the next. But I can already tell that we're not going to be able to get to the answer, because the model has bamboozled itself as we've stepped through the number of iterations. So we have returned the final response, and you can see the quality assessment is false, which means our final response doesn't actually provide an answer. And I'm not going to read all of this, but you can try this out for yourself if you want. But yet the response we've been given does not answer the question that we set initially. All right. So next, I'm going to tally up all of the points scored. So that's a fail for the final question. I'm going to tally up all of the points, and I'm going to put that on the matrix so we can compare how well Llama 3 70 billion did against Llama 3 8 billion and Perplexity. All right, let's tally up the results. So starting with question 1, that was correct. So we awarded 1 point to Llama 3 70 billion. Question 2, we also got correct. So that's a total of 3 points. Question 3, we got correct. That's a total of 6 points. Question 4 was incorrect. So we didn't get to the birthplace of Tyson Fury, which was Wivenshaw, Manchester. Question 5, we managed to identify some cheap flights. So that's another 5 points, leading us up to 11 points in total. Question 6 and 7, we didn't complete. So we landed on 11 points for Llama 3 70 billion. And that puts us, I've put it in between C and B. So slightly below Perplexity, because Perplexity, we did get up to 15 points. So I'm putting it in on that borderline between C and B. So Llama 3 70 billion does fairly well for an open source model. Obviously, we haven't tested the remaining open source models that we have, and some of them, like 5.3 medium, will be interesting to test, and 5.3 small, of course. Mixtral will also be interesting to test, but of the 2 open source models we've tested, should be no surprise that Llama 3 outperformed Llama 3 70 billion Instruct outperforms Llama 3 8 billion Instruct. It's not quite as good as Perplexity. Perplexity did do better on some of those multi-op questions, so it was able to answer the question about Tyson Fury. And I believe it answered, it was the final 2 questions that it didn't get a response to. So yeah, almost there with Llama 3, but not quite. I'll say right now that the result actually did surprise me. I was expecting that Llama 3 70 billion would do a little bit better on those multi-op questions. But what I noticed was a few things. So first of all, the context window of Llama 3 70 billion, I think it's just too small for this custom agent. We've got a context window of about 8.2K tokens. And anytime we read from the Wikipedia page, that context window was breaking. So the context window is too small. Second thing I noticed is as we went through the iterations, the logic and reasoning capabilities of the model did seem to start breaking down, and it got confused and started to bamboozle itself. It lost track of the questions that it had already answered, even though it had that in its context. It was losing track of those questions and leading us into these endless loops and cycles where, we were just continuing to look for the same answers or continue to search the same queries in the search engine. That was a problem with the model. There were points where the model did begin to hallucinate as well. So the notable one was where planning agent come up with a plan and it identified a search query that would be the best search query. And the model that was responsible for turning that plan from the planning agent into a search was taking that best search query and adapting it. So specifically on the South America example, we saw that, showing that the Llama 370B model does still have that capability for hallucinations. It did perform a lot better than the Llama 3 8 billion model by quite a way. The Llama 3 8 billion model wasn't able to get any of those responses. So it did perform better by quite a way. But I still think it's far enough away from Perplexity to say that, yes, the Llama 3 70 billion model doesn't beat Perplexity in this case. Next up, I'll be testing the GPT 3.5 Turbo model. So that would be an interesting use case to see if we can do any better with GPT 3.5 Turbo. If you like this content, give us a thumbs up, subscribe to the channel, and let us know in the comments what models you want tested next. Thanks, and until the next time.